All right, guys, so this is lesson 4, the force of friction. So that's what we're going to be looking at in this series of videos today. So just a little heads up before we get going. This is the video for lesson 4.1. So the first part of the lab for all the way down through 4.1, which is the first page of your science notebook entry for this lab. So this will exclusively be getting started, and 4.1, 4.2, and 4.3 have their own videos. So this is just going to be for 4.1. So at this point, you need to have your science notebook set up. If you don't, pause the video and go and do that. All right, so the learning target for this lab is I can explain why it requires more force to drag a wooden block across different surfaces. So that's you're wanting to be able to explain why it would take more force to drag a block across one surface over another. Your claim that you're going to be writing your CER paragraph on at the end of this lab is going to be, it will require more force to pull a block across rough sandpaper than wax paper. So again, your claim is going to be, it will require more force to pull a block across coarse sandpaper than wax paper. All right, so let's go over the introductions together and we'll work our way through the lab. So this lab is going to be a little different. It doesn't have video by video things to make annotations. A lot of times I'm going to show you a picture or pose a question to you, and that will be what you will answer in your notebook. But the main thing, pay attention to what I'm saying as you are going through the lab and think about what's happening, because you're not going to be able to see everything just because of the nature of this lab. There's no way to individually do everyone, because we'd be looking at 70, 80 videos. All right, so read along with me here. In lessons 2 and 3, you investigated the properties of gravity and elastic forces in rubber bands. In this lesson, you will explore another force, friction. Friction is another force that you experience every day. People spend time, money, and effort to reduce it. You might be surprised to learn that friction is not always bad. It can be very helpful. You'll investigate the force of friction as you pull a wooden block at a constant speed across a surface. As you do so, you'll investigate 3 variables: surface type, weight or load, and surface area or the base area, and determine how each affects the frictional force between the block and the surface. So that's lessons 4.1, 4.2, and 4.3, because you can only look at one variable per lab. In each trial, you will change one variable and keep the others the same. This method is an example of good experimental design. So notice we're only testing one independent variable at a time, which is why we set up the 3 labs independently. As in previous inquiries, you will record observations, collect data, and draw conclusions based on what you discover about friction. Understanding friction will help you understand motion, which is why we study this later in this, which we'll continue to study later in the unit. The learning objectives for this lab are: observe the properties of sliding friction. So let's pause it for a second. Sliding friction involves something that is already moving, hence sliding friction. All right, the next learning objective: measure the force of friction on a wooden block across different surfaces. So you will do that. We're going to have 4 or 5 different surfaces, and you're going to see how friction affects each of the blocks on those surfaces. Measure the force of friction on loads of different weights. So you're going to be using different number of blocks as we go. And then measure the force of friction on a wooden block across with a different base areas in contact with the surface. So, and that's just going to be, you're going to be looking at the blocks and how we use the block. And you'll see the pictures later as we get there. All right, getting started. So in your engineering notebook, you're going to answer some stuff, but we'll get to that when we get to it. So just pay attention to where it tells you to do these things. And I'll also point out that to you. All right, so 1, discuss what you know about friction with your group and the rest of the class. So if you're doing this, you don't really have that option. So take a moment and think about what you already know about friction. Where are some places you've seen friction? Before we go any further, let's just think about a car, for instance. Where would you want there to be friction? Well, if you thought your tires, then yes, exactly. Because friction, what is allow you to stay on the road, it allows you to accelerate or de-accelerate depending on your situation. So if you want to speed up, it lets you speed up. If you want to slow down, it lets you slow down. It's moments where you don't have friction that gets you in trouble when it comes to traction. Because if you lose traction, normally you're hydroplaning or you're sliding on ice, and that's dangerous. Friction isn't always good in cars, though, because friction is what messes up our gas mileage. So if something's grinding or not rolling smoothly, that's increased friction. So that's why we have lubricants and stuff in our cars to help decrease friction in those situations. All right, number 2, identify a situation in which friction works against you. Then identify one in which friction works for you. Think of some situations where friction is low or almost zero. What happens when there's no friction at all? Okay, so there's a lot there. So in your science notebook for number 2, which you've already set up, we're going to break this down so it's not confusing as to what I'm expecting you to do. So let's zoom in right here. I'll take it back out in a second. Number 1, I want you to, not number 1, we're at number 2. So number 2, A, describe a situation where friction works for you, and you should already have this set up in your notebook. So fill in the blank after it. B, a situation where there's little or no friction. And then C, no friction at all. All right, let's zoom back out so we can look at 2. So take a moment and identify these 3 situations in your notebook. They can be good or bad. So pause the video and answer those. All right, so number 3, your teacher will share information about the spring scale to measure the force of friction. So basically on this, we're going to hook a spring scale to a wooden block with a hook on it, and we're going to be dragging it across different surfaces. You'll see in the next couple of slides, there'll be pictures that's going to show you how this stuff was done in class. You're just going to have to use your imagination, but I do have some videos and some pictures so that you see how this lab is done, so you can visualize what we're doing as we go. So again, there's not going to be videos for every single sample. A lot of times I'm just going to show you this is how it was done, and I'm going to talk through the data. And you're going to have to visualize what would have happened in the lab. So make sure you're taking your time on this, because this is your lesson on friction. And before we move on, let's look at the picture at the bottom. What evidence of friction do you see in this photo? Pause and think about that for a second. All right, so if you look at the picture, we can see one of 2 things are happening. And I think it's either the plane is taking off or it's landing. But if you look here, you can see smoke coming from the tires. So it would appear that this plane is in the process of de-accelerating or slowing down from landing. All right, so let's continue. All right, so we are on inquiry 4.1 now. So this is going to be in the procedure section of your science notebook. So let's just go through this and talk about what we're doing. So number 1, this is on pulling a block across different surfaces. So you're going to be using the same block here, except the surface is going to be different for each. And again, I'll show you a video in a moment that's going to show you how the activity is actually done in class. So number 1, it says lay the spring scale on the tabletop. Does this pointer register 0? If not, adjust it to 0. So you're calibrating your scale. If it's not calibrated, that's not an issue for this lab. All right, so number 2, in this inquiry, you'll investigate the force of friction on a block as you pull it across each of the following surfaces. The plain tabletop, which is just our black top tables, wax paper, a paper towel, fine sandpaper, and coarse sandpaper. We'll tape these down to the table and we'll pull it across the length of the surface. It's wanting it to be 27 centimeters so we can track how far it pulls. So 27 centimeters is just short of a foot. It's a little short of 12 inches. All right, number 3, you're going to need to decide on the spring scale to use for your measurements. If you are not sure, try making some measurements of the force needed to pull the block across using the spring scale. The best scale will register the force to pull the block, yet not go off the scale when you exert the maximum force needed to pull the block. So what that's referring to is you want to make sure you're using a spring scale that is strong enough to show a reading and not max out the scale, because some surfaces may require more than the 2 Newton scale, because we have a 2.5 Newton scale and a 10 Newton scale. And your 2.5 Newton scale may not be strong enough. So that's what it's referring to. Make sure you pick a scale that you can read the measurement. All right. Number 4, attach the hook on the spring scale to the round screw on the wooden block as shown in the picture. So notice this is how you'll be hooked up. And the only thing that will be different is you'll be pulling the block across different surfaces. But this is how you'll set it up for each trial. All right, so first thing in your science notebook, how do you think frictional forces on the block will compare as you pull the block across the different surfaces? Write your prediction in your science notebook. So in your science notebook, answer that. How do you think friction, or the frictional forces on the block, will compare as you pull the block across the different surfaces? So go over here where it talks about the different surfaces and how do you think the frictional forces will be different for the different surfaces. All right, so pause the video and make that prediction in your science notebook. All right, number 6 here. This is where you're going to start practicing. So if you were in class, we would actually practice doing this. So when you're taking your measurements on this, we're not measuring the amount of friction in order for it to start moving. So in other words, we're not measuring the force of static friction on each surface. We're measuring sliding friction here. So what we're going to be measuring is how much friction is happening on each surface when it is actually sliding. So I'm going to scroll down to the bottom here and we're going to look at some examples of what I'm talking about. All right, so the first one here is on the tabletop. So notice, not where it gets real jumpy, but once it starts moving, that's what we're looking for. And again, you can't really see this in the video, which is why we're going to be talking about each one individually. So that was the tabletop. And just kind of as we're watching each one of these, watch about how much force it requires. You can just pay attention to the scale. The total amount on the spring scale down here is 2.5 newtons. Sorry, this side. 2.5 newtons is down here. So that's the max these scales are registering. All right, so on wax paper. So again, just pay attention to about where on the scale this is. If its max is 2.5. All right, so now the paper towel. So again, we notice not a whole lot of sliding friction on those. You need to zoom in so you can see. But again, this is fairly qualitative. We're not really getting quantitative data right now. We're going to go over that stuff together as a group on the screen. All right, so this is the fine sandpaper. And then our last one here is the coarse sandpaper. So in class, we would have done 3 trials on each surface and recorded the data on the student sheet for each of these, which we're about to go over together. All right, so let's go back over here. So number 7, you're going to pull the block across each surface, each of the 5 surfaces, and collect the force data for each surface. Make sure you pull it the entire length of the surface, and you're going to record this information on student sheet 4.1, what a drag. And we're going to calculate the average force, but we're going to go through that in a moment. Number 8, graphically represent the average force for each surface. So once we actually go through each data, then you guys are going to construct a bar graph to actually show that. And number 9, we'll come back to in a moment, and we're going to answer these questions. So if you want to pause the video, you can read over these questions. Otherwise, we'll go back to it in a moment. Okay, so you are going to be filling out this sheet as we go through. So you saw what each of these look like. So if you need to back the video up, you can go back and watch each of these videos or the surfaces, and just that way you can kind of see how each surface affected the scale when we were pulling on it. But we're going to go over these together, and we're going to do some calculations. So directions at the top there. Measure the force required to pull the block up across each of the 5 surfaces, calculate the averages, and then you're going to construct a graph to show the values for each surface. So table 1, this is the force needed to move a block 0.27 meters or 27 centimeters over the different surfaces. And again, you just saw the videos on these. If you need to go back, rewind and do so. But we're going to go through and actually take some data. All right, so trial 1, you pulled the block across the tabletop. Trial 1, you got 0.50. Trial 2, on the tabletop, you got 0.5. So 0.54. Third trial, 0.51. And fourth trial, 0.53. And again, these are newtons, what we're talking about. All of these units are newtons. All right, so to average these, you're going to add each of them together and divide them by 4. So you're going to divide your total answer by 4 because there's 4 trials. If you don't remember that, you need to make a note of it because that will be something you have to do on your exam. So if you add 0.5 plus 0.54 plus 0.51 plus 0.53, add that together, divide it by 4, your average is 0.52 newtons. All right, on wax paper, it was a little more difficult. Our first force was 0.60. The second one was 0.65. Third and fourth trial were 0.60. All right, so again, add each of these together. And divide the total number by 4. And you should have gotten 0.60 newtons. All right, paper towel. So this one was a little harder. It was 0.81, 0.79, 0.75, and 0.85. So again, add each of these together, divide it by 4, and you should get 1.9, sorry, wrong number there. So you should get 0.80 newtons. All right. Coarse sandpaper, this was a big jump. Our first trial, we got 1.95. So that one was really hard. 1.85, 1.91, and 1.89. Again, you're going to add all of each of these together and divide by 4. And if you do that, you should get 1.90 newtons. Final was the coarse sandpaper, and it was a little easier than the fine sandpaper, surprisingly. You wouldn't think so, but it was. So 1.6, 2.0, 1.80, 1.8. Add each of these numbers together, divide it by 4, and you should have gotten 1.80 newtons. All right, so let's think about the data here because you're having to visualize this. It was the easiest to pull it across the tabletop. It had the lowest frictional force associated with pulling the block. It was a little harder on the wax paper, required a little more force. The paper towel required a little more force than the wax paper. The sandpaper was almost over double the force required here. So notice from paper towel to fine sandpaper, it was over double the force. And the coarse sandpaper was a little easier to pull than the fine sandpaper. All right, so that is the table there. All right, so now it wants a graphical representation of this. So let's put a title. Our titles come from our X and Y axes. So let's set up our axes real quick. So adjust my iPad here. So draw your line here. Set this up. So we're going to be doing the average force. So average force. That's really hard to see. Give me a second. I'm going to erase that and redo it. So our y-axis is going to be average force. Units are newtons. So again, that y-axis is labeled average force. Our x-axis is going to be labeled surface type. And we will mark the x-axis, skipping a line in between each marker. So the first one is going to be TT. The second one, WP. The third one, PT. See if I can make this a little more fun here. I can. All right. Let's erase these. These are hard to see. All right. I'm going to zoom in here. Well, maybe I won't. This is as far as I can zoom in. So TT. Tabletop, WP, wax paper, PT, paper towel, FS, fine sandpaper, and our last mark will be coarse sandpaper. All right, going up our y-axis, we're going to go every line. So 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4, 1.6, 1.82, and 2.2. So go ahead and label those 0.2, 0.4, 0.6, 0.8, 1.0, 1.2, 1.4, 1.6, 1.8, 2.0, and 2.2. Okay, so let's go through and label these. So what we are going to be graphing is the average force from our table here. So we're going to be graphing these numbers here. So these are the numbers that we're graphing. All right, so the tabletop is going to be first. So the tabletop, we had a average force of 0.52. So it's going to kind of go right about here. So it's going to go from about here down. So something about, nope, it keeps trying to click to a highlighter. So something like this. But this is a bar graph, so make sure you do the bar. We've done these before. All right, so 0.52, 0.60 is going to be our wax paper. So that one's going to go all the way up to the line and down. All right, paper towel was 1.8. So it's going to go about to this line and down. Fine sandpaper was 1.9. So 1.9 is all the way up here. So that's 1.8. So let's go a little higher, kind of get to the middle there. So something like that. Come all the way back down. My graphs aren't as pretty as it is in my other note-taking program, but this is my video one, so it's the best it can be. And the coarse sandpaper was a little less at 1.8. So something like that. So you should have that in your notebook. All right, so let's go over to the side, back to our sheet, and let's see what else we had to do. And we're going to talk about some of these. I work my zoom. All right, so that was number 7 and 8. That was completing the chart that we just did and the graph that you see at the bottom. Make sure you have that in your notebook. You'll need those for tests as well as you will need them for your CER paragraphs. All right, so number 9, in your science notebook, record the answers to the following questions. Which surface required the greatest force to pull the wooden block across it? So look at your graph. Which one had the greatest force needed? So if we look, this one went the highest. So fine sandpaper would be our answer for that one. B, which force required the least force? Well, which one was the smallest? Let's look at our graph. So this one went up to 0.52. That is the smallest number of our averages here. If you look right up here at the top where I'm pointing with the laser, our smallest number is 0.52. So we're answering these questions with our data. All right, C, did the weight of the wooden block change as the surfaces changed? Did we take any weight off the blocks? No, they were just the blocks. So no, the weight remained the same. D, review the variables for this lesson. Which variables did not change as you tested each surface? Okay, so we just talked about one of them. The weight didn't change. What else did we not change? Well, the surface areas didn't change. We used the same surface area on each of these, meaning if I zoom out here, the surface area was the way the block was orientated. So we always drug the block flat on its side. So you can't change more than one thing in an experiment, otherwise you're going to throw off your data. All right, let's see. Anything else? All right, guys, so that completes part 1, which is lesson 4.1. There are still 2 more lessons left. I'm going to post these as separate videos because this is the assignment of the week. So Monday, we are working on 4.1. Tuesday, we'll do 4.2. Wednesday is 4.3. And then Thursday and Friday will be catch up / make sure you have your reflection questions done, or the reflecting on what you've done questions, as well as the reading selections. All of this stuff is posted to Schoology. Make sure you take your notes and fill out your science notebook for each of these. They will be on the test. You will have a quiz next week on friction and a few other things that we're going to talk about as the week goes on, but I'll talk about those in future videos. So if you have questions, please reach out to me on Schoology. This stuff is not hard, but it does require you to actually think through this. So if you have questions, reach out. Otherwise, have a great day.